The Blume Center follows a long history that Stanford's had in earthquake engineering and looking at their effects, starting with the 1906 earthquake. California in general has faced many earthquakes. The Stanford administration understands the earthquake problem, so it makes it very relevant. Over the last, say, 100 years, there's been a lot of developments to make buildings safer against collapse.
My research group introduced the concept of using structures as sensors to monitor humans inside the structures, events happening around the structures, as well as the health status of the structure itself, all through the ambient structural vibration. These structures are continuously interacting with people's inside and the surrounding environment. When people are walking around in the building, every footstep is creating like a small earthquake in this building, and the building will vibrate according to the impact they're giving.
I think some of the work on looking at sensors of characterizing vibrations, looking at the structural health monitoring, which can be under earthquakes, but it can be any structure that's subjected to different types of loading, to be able to infer something about the continued safety of those structures.
Typically we think about concrete and steel as building material. And when we think about how plastics fit into the sustainability of the built environment, I think people need to broaden their viewpoint on this. Combusting hydrocarbons leads to climate change. That's what's producing the CO2. When we turn them into plastics, right, that are then used for decades to build our built environment, we can then recapture them at the end of life, recycle them, build a whole new set of buildings. The question is quite simply, how does that fit within the scale of the built environment, where we're going to be using not just small amounts of these materials, but rather tons. So our work combines both experimental and computational work. So on an experimental side, some of the stuff that we might look at here at the Blume Center is fatigue testing. We'll test those materials with small amounts of load for a few 100,000 cycles. But we don't want to know just a couple 100,000 cycles. We want to know to millions, tens of millions of cycles. So we train our computational models on 0 to 100,000 cycles and then validate them with that same set of experiments and then predict out going forward.
We don't engineer earthquakes here, but rather we're interested in engineering better buildings, better communities. And we do that by interfacing with seismologists to understand the characteristics and the frequency of earthquakes, and also engaging with our students, but also engaging with practicing engineers and also with community leaders, building code officials and so forth, to understand what cities can do to safeguard their communities.